Hello, I'm Jasmine, and if you're working with enDAQ in Python and you're looking to apply your own transformations to your data, here's how we'll do it.
Alright, so if you're working with enDAQ in Python and you're looking to apply your own transformations to the data, here's how we'll do it. So up at the top here, I've used enDAQ.IDE to grab our files and our acceleration channels. And to understand more of what I'm doing up here, you can watch our video on opening an IDE and its channels in Python. So for acceleration channels, the transform attached to the parent channel represents a conversion factor to g's from the accelerometer's units. So we'll want access to the calibration polynomial of the individual subchannels, which we can do with the .transform attribute. And this returns a univariate object here with the calibration equation applied to the subchannel's data. So I'm using the x-axis of the 40G accelerometer, and when we work with channel 8 right after, we'll see a bivariate object that we can work with similarly. So if we want to grab the coefficient terms here, we can call the .coefficients attribute of our univariate object and get a tuple of numbers, and this will be what we change in the next section. So I'm going to do the same here with our 100G accelerometer in channel 8, and since the acceleration recording from my channel 8 comes from a piezoelectric accelerometer, our channel calibration polynomial considers some temperature compensation, so it will be a bivariate. So we have more coefficients to deal with, as you see here. So when I call my coefficients attribute here, we can get the 4 coefficients of all of our terms above. Alright, on to changing the data. So first I'll show my data values so we have some proof that things are changing later on, and I'll use enDAQ.IDE's to Pandas to do so, which you can learn about a little in our enDAQ DataFrames video. So there's our values, and first I'll make the subchannel a little easier to access by placing in a variable, and I'm going to try converting all these values to 0 by reassigning the coefficients attribute of this subchannel's transform object. So I'll pass it a tuple of 4 zeros, for example, but this would be where you determine the transformations that you need. So now if I try to check the data after this, I'll call to Pandas, and what you'll see is that the values will not have changed. This is because we have to make sure to call the channel's update transform method to set it into stone, really. So I'm going to add that here. Now if I run this, the values should in fact adjust to 0. Alright, there's our values. Okay, and there we have it. We have successfully transformed our data. So another note to remember is that changing your transforms through a Python program does not permanently save on the IDE file. If you reopen the file, the transforms will be the same as they originally were, which should be the transforms calculated during your device's calibration. And you can view these on enDAQ Lab with our edit calibration polynomials or through the recording properties.
Thanks for watching. I hope you found this useful. For similar videos, go visit and subscribe to our YouTube channel, enDAQ Technology, and happy coding!